So this is the outline for what we're doing with this training. Boy, and the goal is we're breaking this into 2 parts. We will stop at 4 so that people's heads don't explode. And what I'm hoping we'll do is collect questions about things we want to focus on and cover, and possibly be more dev-centric tomorrow. Today is going to be more overview and demo and what some of the background is. And so we'll go through that. We'll go through those things, and we'll do some whiteboarding. And I have some material about a lot of these things. So let me pull up my PowerPoint so we can talk about it. I'm assuming everybody understands what Crowbar is, or thinks they understand what Crowbar is. But some of the things that we've been doing is really refining in market. Wow. So I'm probably going to skip around a lot of these slides. There's, wow, tons of slides. What Crowbar, the thing that we're really have been fighting back against in the market is that Crowbar was intentionally positioned initially as a OpenStack deployer, then a bare metal deployer, and people really understand Crowbar. It's a great way to position it. We did it intentionally, but the idea that Crowbar is a bare metal installer is sort of a Crowbar 1 mission, and Crowbar 2 we really are repositioning as an operations model. So the idea here is not just that we install things, but that we are getting to a point where we can sustain and maintain in the field. And a lot of the Crowbar 2 enhancements are targeted at being able to do that. This deck has a ton of stuff, and there's a lot of conceptual underpinnings that we would want to put in there. And I'm not going to try and talk through them all here. I actually just did a blog post about this, cloud versus operations, cloud ops, metal ops. So this is, hopefully I'll be very fast, but make this less confusing. Cloud is all about elastic loads, being oversubscribed on your hardware, really simplified models, very, very fast and easy. We live in an operations, Crowbar lives in an operations world where we have to deal with RAID and BIOS, RAID configurations, networking, setting up team networks, right? Getting systems, a specific system fixed and provisioned, not an elastic system. We make the hardware really elastic-like and automated, but we still have to deal with all this. Boy, there's some big concepts. I'm going to come back to these things, probably maybe even tomorrow, where we talk about how the Crowbar engine works and what happens under the covers. The concept of simulated annealing actually comes from conversations that Wayne and all of a sudden I'm blanking on his name. Ward, thank you. Ward were really pushing for what's the model that Crowbar uses. Crowbar 2, unlike Crowbar 1, actually has a lot of baked-in design models. What we do is not exactly simulated annealing, as Victor will happily tell you how badly I break that term.
I've ranted on it for at least an hour.
Yeah, he's not done yet. But what we do is, unlike Crowbar 1, where we sort of say, here's a bar clamp, set it up. In Crowbar 2, we by design did this iterative approach where we try and we tell the system, hey, go set this up for me, and then you tweak it, and then it tries again, and it tries again. So it's this much more of a step-by-step iterative process, which in computer science terms is the closest thing you would find is something called simulated annealing. And the way we do the state machine is also very different, and we'll get to those things a lot.
We have a state machine.
Sorry? We don't exactly have a state machine. We have a lot of little state machines and a baking process by which we jumble all those state machines together and let them do their thing until they're done. So it's really it's fun to watch. It's amazing to watch, actually. The other thing that's really important that you understand is that this concept of late binding, which is another computer science term where we don't make decisions until we have to. So in Crowbar 2, you'll really see this come to light where make a decision, I want to put this role on this node, and it actually builds a whole bunch of other stuff for you right then, including the network configurations and all sorts of things. And then a lot of this also ties back into directed graphs. And in Crowbar 1, we just used ordering, and we said, well, this happens in order slot 10, and this is order 20, and as long as you're consistent, it mostly works. No. In Crowbar 2, this thing happens before that thing, which happens before another thing. So if you ask late bound-wise, I want to be a Nova controller, the system can actually go and say, well, that requires you to go all the way up through to build the whole infrastructure. So you could actually build all of OpenStack by asking for a Nova controller, because all the dependencies up the chain would actually ensure that you get everything you need. Or it would stop and say, I can't do that because you haven't yet positioned a SQL server. Put a SQL server in and come back to me later.
Right now it's set to just build everything using the defaults and then allow you to go and customize it after it's built everything before you commit something.
One of the things that we did in bar clamps, we were very layered. We still have this very layered approach. The layers are expressed in roles. Bar clamps, we sort of hid this, but bar clamps have roles. That's where you allocate the nodes into. In Crowbar 2, roles are really front and center, and bar clamps are almost non-existent. You'll notice that right away. It actually helps make the story about how we do a layered install. And I started with this point. It's not about bootstrapping. It's about ongoing ops. It's really our focus. This is a slide about late binding. I'm not going to spend a lot of time about this. Hopefully you understand why it's important. But this is a really big selling point for Crowbar in general. So here's I guess the money slide for this.
Can somebody mute? I'm getting a lot of static in the background.
It might be the fan. We just moved the phone away from the fan.
Is that better?
Is that better? Oops. No worries. Tony?
Definitely better.
All right.
Sorry, that happens when I start executing all of my slave nodes.
Well, and also the projector's warming up a bit. All right. Let's see. And I just want to make sure that hey, wow, that actually came back just about right. Cool. All right. And this is that. All right. Cool. I'm gonna give up. So what this is meant to do is this is sort of the very high level overview of what's going on. So in Crowbar 2, we actually have a much more, I think the word of the week is rational, approach to how this thing works. And instead of using Chef as our database, we actually have a database, which I don't think you can see on the screen, but it should be there. So inside of the Crowbar engine, we call it the Annealer, bending the term Annealer generously in our behalf. But it's really the orchestration system. It's not a state machine. It controls the node roles, which are our independent state machines. So a lot of independent entities running around in Crowbar. And on top of that, we have a RESTful and a graphical interface. We've created an abstraction layer between Crowbar and Chef, which is called the jig, so that there are actually multiple jigs in the system right now. One of them runs SSH. We call that the script jig. One of them is for testing, the test jig. One of them does nothing, which is the no-op jig. We'll explain as we get detailed why we need a do-nothing jig, but it's important.
Is it Ruby? Is it Ruby on Rails?
No.
No, it has to do with operational needs.
It makes for a good synchronization point.
Exactly, it's a binding point. But most of the work is done by the Chef jig. So those are the jigs. And the workflow is by design remarkably similar to what you're used to. Sledgehammer does a pixie boot, but in this case, and installs the Sledgehammer. Oh, I gotta get focus. And let's see where I go. Ah, that's not what I meant to do. Sorry. So what happens is, this is not the right deck. So what happens is, when it boots that first time, it does a discovery image. But unlike before, where a whole bunch of magic happens on the server side, what happens now is we actually use the Crowbar API to create a node. And so that node creation is actually an API call that then triggers actions to go to the jigs and things like that. So we actually, I can see Victor really spinning up to explain what happens.
The upshot is, well, for those of you that have worked in Sledgehammer before, the upshot is control.sh in Crowbar basically does nothing but register the node if it needs to be registered. And that's correct.
And sets up its SSH key.
Yeah, sets up enough authentication to find the IP addresses we need and let you SSH into the node, and that's it. It's done.
We do. So Sledgehammer is a lot simpler, and we're actually talking about creating a new Sledgehammer for Crowbar 2. That's a much bigger discussion. So, but
that way I can make it even stupider and less dependent on the stuff in Crowbar. Right.
Which also means that you can eliminate pixie booting in Crowbar 2. Maybe. So here's the deal. When this thing sets up, it does a minimal Sledgehammer. The script jig SSHs into the discovered node and installs the Chef client.
Yep.
Okay. That's what the script jig does.
There's a role called Chef client whose entire purpose in life is to install the Chef client and let the rest of the Crowbar framework know that, hey, you can do things with Chef on the node now. Slightly
confusingly, the Chef client role is run by the script jig. The Chef client, and this makes perfect sense if you think about the bootstrapping aspect. Both of the Chef roles are implemented by the script jig. And then all the other roles in the system are implemented by the Chef jig, because they're actually set up and maintained by Chef.
Now, Sledgehammer doesn't install Chef client?
Nope.
No, it doesn't. Nope, the script jig does that for us now.
I don't mean Crowbar 2. I mean Crowbar 1.
Oh, in Crowbar 1 it does.
That's what
Yeah. And it does a whole lot of other stuff, and Control.sh has all sorts of control loops in it that, frankly, we don't need in Crowbar 2. So.
Okay, I was just clarifying my mind what had changed.
That's a great question.
How do you get Sledgehammer on?
Sorry?
Pixie boot, how do you get Sledgehammer on?
You don't need to. You just need to be able to get the keys for the Crowbar server to be able to get the script jig to talk to it. And that's it. That's really the only thing that we have to do for new
How do
OS.
you get Sledgehammer installed?
No, but it uses
You don't
Pixie.
necessarily have to. Like Crowbar 2, it'd be much easier for it to manage virtual nodes or already existing hardware than Crowbar 1.
What does it do?
I'm coming in
installed
with a rack of bare metal.
Oh, no, you still pixie boot that. You still pixie boot
But you
that.
can also come in with, I've got a rack full of machines that already have a boot module. I want Crowbar to manage them.
Or I have a whole bunch of containers, Docker containers, that already have an OS.
It's just got to the point where I can't understand anything.
Okay, sorry.
Because of we're talking over each other. Sorry. Thank you for pointing that out.
There's also a lot of echo on the phone.
Yeah, somebody, if you're not talking, please mute.
So you're saying that the script jig SSHs into a node running Sledgehammer and installs Chef client there?
Yep.
Yep.
Okay. And is the script jig also used to do the same thing to a node after it's initially allocated and has the OS installed on it?
Yes.
Cool. Thank you.
And so as we progress through this build, assuming I can, keep losing, it's weird. So as we progress through this build, what you'll see is we install the operating system, and then the Chef client takes over. I don't know why database came in late. That's an error on the slide build. So basically, the Chef jig still does all this stuff, and the Chef cookbooks that do it are pretty much the same, with the difference of attribute injection. And we're gonna. One of my goals for this session is to get through the discussion of attribute injection.
So what is the database you're using?
Postgres 9.3.
And I forgot to start recording this session.
because SQLite wasn't cutting it when we actually wanted to have concurrency. So Postgres will do concurrency just fine.
Does that mean?
So when you, I have a question. When you show network config, is that your RAID and BIOS yet?
No,
Is that when?
no, that's the network bar clamp.
Right.
So it hasn't happened yet.
It would have happened. It would have happened in Sledgehammer.
Yeah,
Okay.
network config also happens in Sledgehammer as well.
There's some network config in Sledgehammer.
Right now, it's all the same network config that you would get in the OS.
So one of the big differences are, and yeah, I have this. I need to rejigger the build, but the network is not. There is no network JSON.
Okay.
Network is carried through roles. This is really something we should show, not tell about. So I'm gonna hold off on describing the changes to network because it'll make much more sense as we go. Yeah, my build was broken. You guys have already seen all this stuff. You understand how we use the interface mapping to set up network overlays. One change is that we're numbering them now based on, they start at 1 instead of 0, I believe? Or did we do
They
the
start
opposite?
at 0 instead of 1, just like everything else does.
0 instead of 1, everything right.
That inconsistency annoyed me.
So Victor changed that. All right, so this is actually a little simulation that we'll show this when we show the demo. So I'm going to sort of skip it. The idea here is when I don't have a demo, I can show somebody what a simulated annealing run looks like. So I'm going to skip that. This is a visual that sort of helps explain what we're doing with the annealing process, where we start with a very low base state and we add services, resources, and time.
This is the part where I can rant about how we're not actually doing that.
We are. And so what happens is, as you take iterative steps through the process, you add resources, you bring up new services, and so over time the system grows into a more robust thing. But it doesn't have to do it in a scripted way. It does it in a predictable but adjustable, right, late bound way. So this is
So
yeah.
this is going to be completely non-deterministic in the ordering, is what you're saying.
No, this is where Victor gets mad at me for using simulated annealing.
Everything we do right now is deterministic, and therefore it's not simulated annealing.
It's deterministic in this way. So this is where Victor and I see this differently. So when you start making choices, I don't know what choices you're going to make until you start making them. So once you've made a set of choices, Victor can go in and tell you exactly what the system's going to do in response to those choices today. As we get into upgrade scenarios and things like that, it becomes less obvious. But the idea is the system is very predictable in response to stimuli, but it's not predetermined about what you have to do. So we have a graph that says exactly what the dependencies are. Wayne's shaking his head, he doesn't like this. Right, the goal here is that we don't want to tell customers you must do this, you must do that. We want to respond to what they make, the choices they make. And then we want to have a very predictable result. We don't want to have to say, hey, here is a pad of paper, write down what you have before you even start, and then we're going to tell you what, and then you have to make all those decisions in advance.
So by annealing, you mean configuring, right?
I have a problem with predictable.
Annealing is not. Annealing is the process of sorry. Yes, from you. What if you mean by configuring actually going and setting things up on the servers to run? Then yes.
Yes.
If you mean making decisions in config files before they get set up, then no.
No.
Annealing is the actual process of doing the install.
At least that's the term we're using.
That's
for it. It's not really simulating annealing would be a layer that drives what we currently have.
Right, would be a layer above it. Yes. Yeah. That's right. You guys know that this is about OpenStack, so there's a lot of moving parts. I'm going to skip all this stuff. You guys should also be familiar with this, which is that there's a when we do an orchestration, we're actually doing a lot of different pieces, right? We have to do node. This is sort of everything flipped on its side, but it's showing just that we have a lot of stuff to keep track of. You've hopefully seen all these slides. These have been around for years now, showing how we build up the infrastructure and layers. This is a slide I've been trying to get to. So when we started, I built these almost 18 months ago. And because we're actually working against the plan, they're still relevant. The idea here is that we're building up from the bottom. So first we paid down our technical debt, and we switched to Chef 11, we put in a database, we designed an API, we put in integrated testing, we started writing a docs framework. All those things we built first. Those have been in the product for a year now. And then on top of that, we figured out how to do the networking in a coherent way so that we could get rid of network JSON. The number one problem that people encounter in the field was that. And then on top of that, we started doing things like enabling node multi-operating system. So one of the things that we could consider doing, we were talking about CentOS versus Ubuntu on the way over. It might be easier for us to keep the admin node in Ubuntu and just turn on multi-OS support so that you can install CentOS as the child nodes, and that would actually accomplish this. One of our goals. Making the deployer pluggable. So in this case, allowing you to, the jig abstractions was a big piece of this. Being able to extend the orchestration. So what we've done with bar clamps and roles, you'll find actually very extensible. Online caching, we haven't spent as much time or any time doing, and we'll have to talk about that at some point. And the purpose here is that is Crowbar 2. We're laying the foundation for high availability and auto upgrading and things like that. Crowbar 2 doesn't do those things. It's not expected to do those things. All we're trying to do is make a system that we can start doing those things on top of. Okay, so it's really important not to think that we have completed. This is Nirvana. Crowbar 2 is a foundation. At one point we were talking about it as Crowbar 2 Core, Crowbar 2 Base. And we expect there's a tremendous amount of innovation that's going to happen on top of this base platform. That's the purpose here. And then I actually have backup slides talking about how these individual things work that I'm not going to spend. I'd rather show than tell on this.
Some of those are actually good to go through, specifically the lessons part with this team.
Oh, good point. I'd be happy to do that. So, yeah, so everything we're doing here is really the result of a lot of field experience on Crowbar 1. Everybody on the team has learned this the hard way. So in networking, right, the first thing we know is that configuring networking is a huge differentiator in the field. It makes a tremendous difference in deployments. Nobody else does it. And the fact that we can script a network change is amazing. The conduits especially were very powerful. I think we extend those in Crowbar 2 in positive ways. But network JSON was making people's head explode. To this date, I think there's only 2 or 3 people who can rationally create and edit a network JSON file. And even that.
All on this phone call.
Yes, all on this phone call. Or working someplace where they won't come work for us again. Damn it. So, clearly we had to fix that. And the other thing about it is that there's a lot of things that we want to change in the networking that are, really post-install decisions. In a lot of cases, they are related to being able to connect to an online cache and change things, right? Like a lot of the features that people want in the next couple slides, we can't do in advance of the install. We actually have to be able to late bind our networking. So those were really important. Multi-OS, as much as our customers, try and standardize, they all are multi-OS. Either that from VMware and Windows plus Linux, or 2 flavors of Linux, or 2 versions of Linux, right? They're on CentOS or RHEL 6, They know they're going to have to. We know they're going to be migrating to RHEL 7 sometime in the near future because that's coming out. They're all faced with that. So that's been really important. One of the things that's interesting for us and our team is that by being multi-OS, we actually help shift the balance of power from the operating system vendors back to Dell. Because our conversations don't have to start with what operating system do you want to use, and then the relationship goes to Red Hat or Ubuntu. It can be, hey, if you want to switch from Red Hat to SUSE or Ubuntu to SUSE, anybody to SUSE, then we can allow you to do that in a more graceful way. So, yes?
So we carry the ISO for the OS? Doing multi-OS?
Maybe, maybe not.
We still
technically don't have to right now. Well, in online mode, the way it was implemented in the tree before we formalized the Crowbar 2 split, if you flip the conversion into online mode, it would go out and fetch just the kernel and the init RD that we need to bootstrap a node, and then all the rest of the install happened over the caching proxy that was set up on the admin node. So you didn't have to go out and fetch a new ISO for each operating system. It just
More simplistic that the user want to and ISO want to share.
you do that too.
And so, there's a couple ways to skin this cat. We definitely still have the problem of needing to be a complete data center on a disk. However, we also need to be able to let people to switch out of that mode once they've started. That's been.
So will the admin node always be like Ubuntu, and then all the other nodes can be whatever flavor you want?
No.
No.
Our goal is to let people choose their admin node install. There's a couple ways to do that.
Kind of like what we have in Crowbar 1. Our primary limiting point right now is Ruby and the lack of Ruby 1.9 on CentOS by default.
So we need to figure that out. But once again, if we're multi-OS, you could install the admin node on one OS and then deploy a different OS. The challenge is if you wanted to say start on Ubuntu and deploy Cent, and this is why we don't. This is why we don't do this. If you wanted to do that, then we'd have to include both in the ISO, and the ISO would be 7 gigs, which is prohibitive. So the reason we have only one OS for Crowbar 1 is predominantly because of packaging size. It's packaging size. So we reuse the ISO that we deploy off of, like the image we deploy.
So, how are we going to deal with different stacks that are OS dependent? So, some software stacks will run differently on top of the OS than not.
Right now, it's switch statements inside the cookbooks, and I don't expect that to change. There's ways within the cookbooks because there's a cookbook problem even more than a Crowbar problem.
Yeah.
And so we actually could start taking jigs and bubbling it up and handling it at the orchestration level if we ultimately needed to.
We're going to have to do that.
Potentially.
Right now, whenever you
will do that.
right now, basically all of the Chef cookbooks out there that pretend to run on multiple operating systems have what amounts to a whole crap load of switch statements for where the operating system's different.
So you need to abstract it.
Perhaps. And
so if we're going to be working with upstream cookbooks, we can't abstract from that realistically.
So hold on a second. I want to. There's two things. There are two things here. Yeah, but the design paradigm that we have followed is emergent design. All right. So you are going to find a lot of places where Victor and I will answer, we think that's reasonable to do, but we haven't done it, or we have 2 ways to do it, we haven't made that decision yet, or we've just left that as terra incognita. And that is good. There's a lot of, our goal was to get the minimum basis up that we thought was stable and quality. If we felt like we could postpone a decision, we always did. Which leaves opportunities for design as we go.
Yeah, there's still things that need to be fleshed out in the Crowbar 2 design, but we've got enough so that other people can start working on it.
So this is a really important feature set that right now in Crowbar 2, we haven't done any material work on this. Pluggable deployer. This is the whole jig infrastructure. I started to modify the language, but it's not on this set of slides, so I need to pull it back to this deck. But what we found is customers felt we were way too integrated with Chef, clearly. A lot of customers wanted things besides Chef. Salt is actually rising in popularity faster than Puppet. Ansible is another technology people are interested in. Juju even. So it's definitely possible, and we'll describe how this works. We did this very carefully, especially because we had the script jig is an equal jig to the Chef jig. So we already have multiple working jigs. Somebody could even use the script jig to do deployments if they wanted. But this is a major capability. Hopefully it won't. I found in using Crowbar 2, it doesn't cause me a lot of thinking, which is the way we wanted it. But it's important to understand as you start doing cookbooks how this works. And then
question.
Yeah.
So currently in Crowbar 2, can you actually have multiple deployers functional at the same time in one Crowbar 2.0 installation?
We do. It currently is, because the script jig is an equal deployer to the Chef jig. But a individual role, this is one of the big changes from the last design pass. Individual roles are not, a role is only bound to one jig. So you can't have a role that's deployed by two different jigs. So it really simplified the situation. When we have the OS provisioner role, it is a Chef jig role.
If we have a heterogeneous node environment where some of the nodes are CentOS, some are Windows, we might need different jigs for the same one.
We might. And
it's not precluded by your design?
It is not precluded, we haven't done it.
We just haven't done it, okay.
And
we'll
right
get there. If we wind up needing to do that, we'll make that decision at that point. We are not going to preload that decision.
I was just wondering.
Yeah. We've thought about it a fair bit, but we've decided not to act. So, right, and right now we only allow nodes. There's a whole bunch of places we created more restrictive design decisions than we think we ultimately will have. You're not allowed to have duplicate node names because we recognize that at some point we want to break that. We figured it was easier to be restricted now than later. You'll see there's a ton of places where we've basically kept our options open by being very restrictive now.
So if you had a strange situation where you had both Chef and Puppet as deployers functional at the same time, then for a bar clamp, that would mean that you would have to have a separate role for each deployer, and then by extension, a separate Chef recipe and Puppet, I don't know what you call it, recipe module as well, right?
Correct. That is, you're going to have that. The question is how to resolve it. We are not trying to make it generic out of the box.
Okay.
One of the reasons why the no-op jig becomes very interesting, though, to run that down just a little bit further, is that you could actually use the no-op jig as the connection point between them, and you could have a Puppet chain of roles and a Chef chain of roles that did the same thing, that both relied on the same no-op jig. So that way you could then chain them back together. You'll have to see how we did the directed graph, but that's how you would make these chains work. Because while one role is tied to one jig, roles are tied to each other, not jigs. So you could bounce back and forth between different jigs. As a matter of fact, we do with the script jig and the no-op jig.
The script and the no-op and the Chef jig, we bounce back and forth between them all the time. Right. And they all seamlessly inherit attributes from each other.
Crowbar doesn't care about the jig per se. That's an implementation decision at the object level, so to speak. But the orchestration, so the orchestration works at the role level, and then just delegates it to the appropriate jig. Yeah. It's actually pretty well decoupled, which was the design goal that we've just been going through. We have not done events. We have there's no eventing system. We actually pulled out all the eventing logic out of Crowbar. Crowbar is asynchronous at the node role level. We'll explain what node roles are. So it does a lot of things asynchronously and in parallel, but it does not have events in the classic sense. There are quite a few there's quite a few on actions that are wired into our object models, but those are synchronous. So if you're expecting our on node create action to be asynchronous or an event, it's not. It's a synchronous override. You'll see this when we probably tomorrow when we go through the models in detail. The asynchronicity in Crowbar is always, we've always directed it back to the node roles where there's little tiny state machines, and I think I have do I have graphs about that? I don't. I'm going to keep going on these. This is internet connected mode. We haven't made a lot of progress on this, so I'm not going to spend time talking about it, but this would be where you would, once Crowbar is set up, you connect it to an outbound interface and you can bring things in. This is essential for upgrade, and we just haven't worried about it too much yet. All right. Okay. So there's that, and then I think what I'm going to do is not try and talk through the node role state machines right now.
Got like an hour.
Because I'd rather jump into demo, if that's right. So we've gone through a whole bunch of background. Yay, and I see people are making notes. Thank you. If I can find my mouse. And yeah, I'm not going to talk about some of these things, although I can. Yeah.
Does Chef Client run on the admin node?
Yes.
Yes. But it doesn't.
To do.
Well, we still set up, like the provisioner and all that stuff is still set up using Chef. I'm not going to throw those perfectly good recipes away.
As a matter of fact, Crowbar 2 install doesn't install anything except a web server and a database anymore.
I'm not concerned about that. I'm just concerned about the issue of as you're managing more nodes, the Crowbar, the Chef Client run on the admin node becomes the performance bottleneck.
That's always what's wind up not becoming a performance bottleneck.
I know, and I was asking, did we take care of that performance bottleneck?
We've alleviated it somewhat by being very targeted about what roles we say need to run or even run.
So we don't run all of them on it.
We only run what's needed.
Right.
And we've also taken care of it. Chef 11 is a heck of a lot faster in doing that than Chef 10 was.
That's not to say the Chef Client is a heck of a lot faster.
It is, actually.
It is, and also things that are very small tweaks that would cause a lot of Chef Client runs, we actually handle directly. So something like adding a DNS entry no longer requires a Chef Client run.
It still does, but it's a much more targeted one. And a lot of the things that were shown that were slowing the Chef Client runs down were things like every time we needed to do something, it seemed like we were having to go back to the Chef server to do a search. So adding another round trip, another hidden couch DB or whatever. But since Crowbar 2 is handled attribute injection for us, a lot of those searches are gone. So the Chef Client's interaction with the Chef server is limited to get the node data, get the role data, get my cookbooks, plow through them all, and send the results back, which is a much faster process.
So
you offset the Chef Client runs on those random data thing you introduce.
We actually don't do recurring Chef Client runs at all right now. Every Chef Client run that happens on a node for any reason is kicked off by SSHing the node around the Chef Client.
We really don't use
approach,
the server.
But it's the approach that works right now. If we need something more innate, we'll do it when we need it. That's part of the whole. We aren't trying to pre-design. There are several possible other ways that we could do this, but I'm choosing the most simplest and direct route for now.
We could do there's Chef eventing and all sorts of things we could do.
Yeah. If Judd were here, he could go on about that for a long time.
Right. So we're not trying to fix problems we don't have. Yeah. eventually that would be something we should be able to do in these designs. Yes, especially with the script jig as a client, because we can't install anything in it.
Or it's not needing to use Chef for everything.
So yes, but you might end up needing a VMware jig, frankly, which would be fun. Not even that hard to write.
Talk about jigs. I don't know if it's been said yet, but the responsibility of the jig is to push attributes onto a node, run things on it using whatever, scripts, chef client, whatever, and suck attributes back out. That's pretty much the only point of interaction between the Crowbar framework and the jigs. So whenever we're talking about that's how we isolate. That's how we isolate the details of what has to happen for Chef to do its thing out from everything else, and how we make the framework not care. As long as it can push attributes in, run things, get attributes back, that's all it needs.
Very, and we'll talk. This will make sense a lot more as we go through what attribute injection is and how it works, because part of that is we figure out what we need to tell the jig during the run, and we give it the information it needs to act, no more, no less. And one of the important things about that is that we eliminate search. So scoping for deployment is not done in the cookbook, it's actually done by Crowbar. So Crowbar says this is the information you need on the nodes you need to know about, not Chef. And thereby, when you don't have to figure out your scoping boundaries for your Chef searches anymore, which is one of the places we fall down really fast at scale. Okay, so I was going to pause here and switch to demo. Is there something else I should cover from a background perspective? Scott, is there something else that we need to talk about from a background perspective?
I don't think so. I mean, I think the only other one that's really worthy of note is that one of the technical debt items is actually scale. That is what we're really trying to tackle with this as well.
How big is this one going to go? Previous was, according to note here, 60. I've heard that number 4. How big will 2 go?
Our design target is approximately 1,000 nodes. At that point, that's where I expect the core node role traversal graph algorithms to start slowing down too much.
1,000 nodes with one admin?
Yeah. Or several federated admin nodes. But that's where I expect the core data structures to start hitting their scaling walls.
We have lower release target numbers that we're going to want to hit, but what we're finding is that in the market now, before 60 was actually fine. That was actually a pretty good sized cluster. That's kind of not the case anymore.
Yeah.
Actually, at all. So that limitation is actually killing us.
If you're moving beyond just installation, you've got ongoing performance as well, which is going to be far more interesting.
Yeah.
Because they are by
Hey, Rob?
definition asynchronous.
Another thing that might be worth mentioning is just the implementation details, that there's still a lot of commonality with Crowbar 1, so it's a Ruby on Rails app and so on. Just in case anybody's confused, it's not a complete rewrite.
It almost is.
Yeah,
actually.
I would prefer not to confuse people.
And the reason that I say that is that Crowbar 1 was Ruby on Rails without active record, and instead slamming a shim layer that talked directly to the Chef database, which meant that your data models were by necessity a lot different than what you would expect from a standard Ruby on Rails app.
Right.
This is in fact pretty much a bog standard Ruby on Rails app. It talks to a database. The only difference is it also knows how to go out and talk to jigs, which allow it to control other systems.
Yeah,
I think that was my point.
Yeah.
There's some things that we kept, but for the most part, I think every line of code is different. I would be.
Some of the ideas are similar, but
I would be stunned to find overlapping lines of code between the two products, because they use a whole different data model, right? And it's a whole, and one of the things that was really significant. Actually, let me pull up the model. So we actually have this is actually a really useful thing to pull up. Okay, so in the doc dev guide model, there is this. Yep, pulled it up on the wrong screen. I think this is still relatively up to date because we haven't changed the data model much in the last couple months. So this is the rough schema of Crowbar 2.
Yeah, that's okay.
It's pretty accurate because we haven't added much since we figured this out. So one of the cool things is that if you went back to February, was it June, July, when we actually sat down and had that meeting to figure out what to do in the revisit of Crowbar 2.
Mm-hmm.
What we figured out in that meeting, we've pretty much done. From the node role state machine to the deployment architecture, all those things are done. The thing in this, and you'll see this when we run the app, the center of Crowbar 2 is the node role. We talked about changing the name for this. I think that window is closed. Node role, so node role is the thing. If you ever get lost in Crowbar 2, come back to node roles and you will figure it out. A node role is the intersection of a node and a service that we put on that. So a role, we call it roles. The roles are all service type things, but they're also networks. They're relationships for things. But so the node roles, and there are thousands of them, effectively describe your deployment.
Yeah, I mean, in a simple 5-node deployment, 1 admin, 4 computes, just bringing up the node, you've got about 100 node roles in the graph.
I'm going to click the run button.
Yeah.
So, right. And each node role has its own state.
I think it's Judd. He just called me a lot too.
So this is the way Crowbar 2 works, and this is really the central thing to understand. Node roles have their own state. So in every node role, it starts off in a proposed state where the user can edit it. And we have a state machine picture for this, which I think I can bring up. Node role states, cleverly described. So here is our friend the node role state graph.
That red is just not working.
It doesn't work on the screen. I'll talk through it too. I'll talk through it. So basically, if you understand this graph, and it's really easy to understand, luckily, then you understand Crowbar 2. Pretty much.
Mm-hmm.
So what happens is a node role starts at proposed, the user edits it and commits it. We intentionally use the same language, but correctly, that we use in Crowbar 1. So from that proposal state, the user commits that proposal, right? In reality, a proposal is a bunch of node roles, but every node role is an independent state machine. They interact through their state transitions, but they're themselves. From that commitment, it looks at its graph. So it has upstream requirements and downstream dependencies.
It has parents and children.
Parents and children. And it looks at it and says, of all my parents, are they ready? If they're all ready, then it puts itself into do state. It's unblocked. If any one of those dependencies are not met, it says, oh, I'm blocked, I can't do anything. So it makes those decisions. That informs the annealer that this node role can be given to the jig or not. So if it's in a to-do state, the annealer can pick it up and say, I can work with you. And it goes and anneals it. The annealer is where it actually transitions from control of the crowbar to the jig. So once it's being annealed, the jig manages it. The jig takes that, does whatever it needs to do, and this is a multi-threaded process. So 10 of these things can be happening in parallel. They're single-threaded per node, but if you have 10 nodes, you're going to get 10 simultaneous actions. It spindles it, it mutilates it, does whatever it needs to do. When the jig is done, it says either it worked, switch the state to active, it failed, switch the state to error. Okay, that's the outcome of the jig doing its work. From there, two things can happen. If it's an error, the user can put that node back into do, which is effectively a retry. So if the user chooses to retry that node role, it's going to go into to-do state.
Or blocked.
Or blocked, right? Or blocked.
Yeah, so that graph needs to go up and want to be unblocked.
Unblocked. Yes, you're right. Thank you. And then, but if it's active, what it does is it says, I'm done. This node roll effectively is quiesced. And then the annealer goes in and looks at all the downstream node rolls that are blocked. At first it looks at all the to-dos and takes those off the queue. But as soon as something goes to active, all the dependencies are evaluated. And if any of them can be unblocked, it unblocks them and makes them to-do. So what happens is you've basically got this very atomic, there's all these little atoms running around these node rolls, and they will impact each other's states, and you create this wave effect of each thing is running. As it gets run, it unblocks other work is unblocked, it's acted on, it's finished. There is no concept of a node state or a deployment state. Those things are entirely bubbled up from the node rolls. So
well, there is a concept of a deployment state now.
There is from an archival perspective.
Yeah, it more has to do with what happens when you make changes to a deployment. It doesn't have anything to do with the node roll graph.
So a deployment is really. Go ahead, Derek. I can see you have a question.
I'm struggling to see where the control layer is. If you have something that needs to be completed on one node before something can take place and not be finished on another node. I don't see where that.
If you have that relationship, it's explicitly modeled in the node roll graph. So once whatever node roll on a node transitions to active, if something else on another node depends on it, then it's ready to go.
What? I'm sorry, you broke up there for a second.
Yeah, this is another easier to show than tell.
Yeah. So when you're talking about node rolls, all node rolls essentially can have parents and children. And together that forms a gigantic directed acyclic graph that encapsulates the entire state of where the cluster is and where you want it to be.
Right.
And so node rolls can depend on any other node rolls as long as it doesn't create a circular dependency. And so like to be a lot more concrete about it, I just went ahead and loaded a 4-node cluster. One of the nodes out there or one of the node rolls out there that sits on there is a node roll that says DNS server runs on the admin node. That's active, so the DNS server is up and running on the admin node. Then every other node, including the admin node, has a separate role that says DNS client, which is essentially says, resolve conf, you should use this DNS server. And so all of the DNS client node roles on all of the nodes have a dependency that points back to the node role, to the DNS server node role on the admin node. And so when it became ready, or when it transitioned to active, all the DNS client node roles transitioned to to-do and they could do their thing.
How about dependencies control that?
There is no such thing in Crowbar.
So
that's why we have a no-op.
So these dependencies, the dependency of those NTP clients on the NTP server is determined when?
Whenever you are creating
in the bar clamp definition. When you define in the bar clamp, you define the roles.
So,
in the roles, in that definition, you define the dependencies.
So NTP server is an abstract thing that some other role can reference as a dependence.
Right. You remember the mess we had with instance and not instance in the original design? Well, that's gone. The concept between a role and a node role in a way is an instance of a role from that perspective. So roles are the abstract thing in this case, and role requires is the relationship. So on the left side of this graph, role requires is the graph, but you don't implement that. You actually implement the node role graph, and what's missing in this is there's actually another set of tables that implements the node role graph specifically for your deployment.
So when you deploy is the binding time for all that. When you apply it.
When you propose it right now, when you propose a new node role relationship, it builds the graph behind it, and only then. Okay, so that's that, and most of this is pretty straightforward. So we talked about jigs a whole bunch. Jig, a role is implemented by a jig specifically. A bar clamp is a group of roles. A deployment should be pretty straightforward. It's a scoping boundary. Right now we have a system deployment that you can't mess with. It's used for node discovery. And when you want to actually make changes to the system, you create a child of the system deployment. And we only allow one level, and that level are all children of system. But the idea is that that's the scoping boundary. So when you create when you want to create an actual deployment of Ceph or OpenStack or Hadoop, you put nodes in that deployment boundary, and then you create node roles within that boundary. So the idea is a deployment is actually a scope boundary. Although it's important to understand there's really only one node role graph. The scope boundary is
it determines how dependencies are resolved, essentially.
Right.
So, see why this works fine for deployment. My understanding of what you said, which will certainly be badly flawed, an ongoing management situation is making the assumption that you are the only management tool in this universe, in this control space.
yes.
That's not hard.
It might cause problems.
It would.
I keep imagining that you'll have to address the problem of having multiple admins cooperating in operation.
Yes.
There is no way anybody's going to turn over the operation of a place, a domain, to just one tool. Because there will be things we can't deal with, and they will have to be fixed. So we have to respond to triggers that are not modeled in a node.
And that's fine. I don't.
Yeah,
We haven't gotten there yet, but I'm
for
sure we'll do it. I'm sure that'll be.
Yeah.
We'll find a way to do it.
I just don't want to try to implement design for something that we don't have an actual design.
I can give you examples.
I'm sure.
I've got some of them burned on my psyche, believe
Right.
me.
So these are, and what I love to do is have hallway conversations about this stuff and talk through the designs and
I
stuff
just
like
want
that.
to make sure that I'm understanding limitations.
This is definitely a single master system. One of the things that we tried to do with Chef when we did our original design was that we thought people would use Chef and keep the system running on Chef, and we'd have to absorb changes from Chef.
That never happened.
And that has not proven to be a useful model. So we actually started more on the other side of that equation. The last, there's two things I'll cover quickly, and then I think we should go to demo on this. Snapshot is, we've been trying to make snapshot less obvious because it's confusing to people. It's unnecessarily confusing. But remember when I showed you the annealer and I showed you this layered deployment? A deployment is a persistent thing that you keep working with, and it changes over time. Every time you commit, what you're really doing is you're taking a point-in-time snapshot of that deployment. And so we actually make a full copy of the node role graph for each one of those events. So if I'm going to create a proposal, I create a copy of my node role. It's actually not a full copy anymore.
We don't actually copy it all anymore if we don't have to.
This is why we added some state here. So we actually make a shallow copy of the node role graph based on a snapshot. If you can start editing them,
Just the relevant parts.
we only make copies when you start making proposals. If a node role switches into a proposed state, then we have to make copies of it. But if it doesn't, then we don't have to make copies because we assume we don't have to retouch it.
It's still not clear. So there's a node role graph that you can imagine contains every expressed role that's out installed on the system.
Right.
And then if you change one of the proposals, do you make a copy of that entire graph or
Just the impacted node roles.
Just the thing that changed.
Okay. Okay.
Well, and the downstream dependencies that are going to have to be
We
tweaked.
don't actually change those anymore.
Okay.
Okay.
What's the purpose of that? To roll back if you need to, or?
It's really impossible to actually roll back in the real world. You can just roll forward to a previous state.
Correct. That's the model. It's roll forward to previous state. That is, there's no way to undo.
Yeah,
Or just reset.
Right.
basically, yeah.
But the idea, but the purpose of creating these snapshots is to we do want to preserve what the decisions we made in the past.
So just for information of history?
At this point, it's mostly
basic
just
for history.
We'll leave rolling trails.
Right. It's also important when you do a proposal that you start with the state that you have, and if you mess with it, that we actually can compare what we have to what we want.
We haven't actually baked any of that in the UI yet, but
We haven't.
we got through there.
And attributes right now, they might get a little bit more complex, but they're actually very simple. What they do is we pull back a whole bunch of discovered data for every node. Attributes are just a convenience method to retrieve specific
So we keep
things
talking
out
and
of
not
that.
doing it.
Bring it. I'm done.
Fortunately, I don't have BGA output.
No, just give me a Skype output, please. That works really well, and I will throw it on the
So
screen.
what I should probably do is my world famous demo of deploying Ceph.
Oh, you're not
Because
going to
it's
start.
not
You're
like-
not going to start from scratch.
Well, I could start from scratch, but how bored do people want to get?
I think that there's going to be a lot of questions even though I start from scratch.
Okay, let me kill what
Yeah,
I've
I
got.
think start from scratch is probably pretty important.
Okay.
So while you queue that up and then call me on Skype, I will explain. So DevTool builds are pretty much the same as they always have been. So you can switch to deployment master. You might want to do it on a new VM if you're using a new build VM because it needs Ruby 1.9. It has a different cache and all that. So if you're going to do a build, I would recommend a new VM or a new path for it, just to keep yourself eat cleaner. But DevTool works pretty much the same way, with the addition of you can actually run Crowbar 2 from the command line in test mode. So you can actually run the website, you can create simulated nodes, you can run the BDD infrastructure. We've done some trainings on that. We'll train again on it. So before you do a commit, you can actually run an integration test against Crowbar 2.
This is not working.
Echo limiting functionality.
There, this is the especially boring part, just doing the first pass bootstrapping of my admin.
Oh, we can't turn off the lights, can we?
It's pretty hideous. No use.
Yeah, the challenge is we're using the black on black screen stuff. Oops, and we lost it?
No, I just switched screens.
Oh, okay.
Oh, the problem here is also the resolution of that kind of sucks.
Yes. Yeah, the resolution of the projector is low. So DevTool is the same. The install is different, but only minimally different. It's still install Crowbar, provide the name of the server. Right now, if you do not include -- wizard, it will automatically run Crowbar all the way through its setup, right? If you include -- wizard, what it will do is it will stop before it completes the install.
Actually, let me hang up and then start it again. I
Okay.
cranked my resolution down so it'll look better.
That's fine.
Is there some kind of smoke test? Is there a dash test level?
In dev mode, there is a /dev tests server or tests run.
And that uses Docker.
But that does not use Docker yet. Docker's actually is a production mode
Yeah.
test. Wow.
There's
I
that.
wish you could turn off lights. I didn't think about reserving a room that you turn off lights in. This and
Just turn it off. Leave the door open.
if you can leave the door open, just let some light.
It's doing its motions inside.
Yeah, we're
Stay.
stuck. We're stuck on that.
It's freeze.
we need to probably put the white skins here rather than there. So the wizard, and that you're using the automated install, so the wizards, you can catch it and watch the bootstrap. So,
Rob, is the initial part that you do before this is still the same? You mount the ISO to like a VMware player or VMware workstation and then starts it?
totally yes.
Okay.
Yeah, wow, that,
Away without doing it.
that
that's-
just sucks.
Yeah, it's not very good. So, yes, exactly the same. We've worked hard to keep the install very similar. And if you don't provide any input parameters, it'll automatically set up the admin network for you and register the admin node for you and do things like that. If you don't do those, if you use the wizard install, it won't do anything. It just sets up the database and the website, and then you actually have to define the admin network. So there's a spot there's a bootstrapping wizard. You actually have to define the admin network, and that lets you set the ranges the admin node's going to use, and so all the networking that you used to do is actually not done for you until after you go and do these steps. So there's 5.
So the entire contents of the network JSON, like setting ranges for DMC IPs and node IPs, is that all there?
Gone.
All gone.
No, is it all there in this wizard?
The wizard only does the minimal things that you have to have.
The wizard only does the admin network.
Okay.
That's it.
Correct. The other networks are set up dynamically as they're needed.
Yeah, and when
And
we
that's
start
the
talking about
Crowbar
implementing the
UI.
IP my bar clip, we'll have
That's
to
using the Crowbar
design
UI.
what we need to make it that work as well. So.
Do you still configure your switches with the same VLAN though, with 200, 300, etc.?
The choice of VLAN numbers was kind of arbitrary, anyways.
But yeah, we'll probably have the same defaults.
Yeah.
It does set up defaults.
Do you have to build the ISO for a specific operating system for the admin node, or is it, can you choose
Yeah,
it
we still have to do that.
So
Yeah.
we'll end up having ISOs for different operating systems.
That part hasn't changed yet, and I don't realistically, I don't expect it to change that much. If anything, we'll be adding more operating systems that we can build onto.
That's only for the admin node, but not for the nodes that we manage. Right?
That will rely on us getting the multi-OS stuff worked and working in the same fashion. For now, though, just to make our life simpler, I haven't tried to do anything but Ubuntu 12.04. It's because it's easier to get things working on other operating systems, less than working on the first one, correct?
That's something we expect to start branching out, and that's once again the goal for the pivot was to get to a point where people could be successful in parallel with us. And multi-OS is definitely a parallel activity.
But what is the OS? Is there long-term support for OSs for the admin node? Can be Tuesday, Ubuntu, Red Hat, Windows?
So that's a very tangled up
Almost
question.
certainly not Windows. That would be quite the trick.
We will support Hyper-V though for nodes, right?
Yes, but not as an admin node.
And I want to be very clear on what support means. So we expect a lot of things to be in the community and possible to do in the community. I think I'll channel Scott. Scott can confirm me. We are trying out of Dell's labs to only have one OS that we support. And so if a customer comes up and says, I want to use Fedora because it works in the community, then they're on their own. We will certify.
So right now,
only
we're
one
not finished
thing.
with the install
Good.
because we're going through and doing our migrations for all of our bar clamps, which we really don't need to do right now, but we do it anyways. But
It's probably easier to read off the screens.
the web server is up and running. We have no nodes yet.
Nodes.
And we can go and look at the shiny wizard, which would allow us to configure our default DNS settings. Like if we wanted to point it upstream DNS servers as forwarders, we could do that. If we wanted to use an external NTP server, we could configure here before we created our default nodes.
And those are actually using the overlays. So like we do in Crowbar 1, we have overlays for roles. These are actually overlays.
If we want to edit it right now, the network server role is what, it's basically the thing that holds our bus maps for overriding the ordering of what we consider to be, you know, the first interface, the second interface, and so on. If we wanted to talk to an external chef server, eventually you'd be able to do that here. Right now you can't. We always deploy our own chef server. And you'd be able to add a network admin and configure it away from the defaults. And once that is done, create the default admin node, and then the Crowbar framework is up and running, and it will start its own annealing process.
Do you have to deploy the DNS piece first before, let's say, for MTPs, and you put a qualified name in there, or do you have to do IP address, or?
So you don't. It'll do it for you. We haven't tested the case where you actually say don't install one for me. Remember, there's nothing installed yet.
All right.
It's,
I'm just thinking you have to put an MTP server IP address, or you put a qualified name, right?
Probably safest to use an IP address for that sort of thing right now. I haven't actually tested any of that yet, so.
The long term that'll be supported, I imagine, right?
Mm-hmm. Should be.
So we're waiting for it to click that button.
Now we've
for
gone
us.
through all the migrations. We're bouncing the web server. Or at least I have, y'all haven't yet. And it's created its admin node. It's created its default network config. Created its admin node.
You want to jump over to the website? Because it effectively at this point has pushed the buttons. The buttons use the API, so it's effectively done the API change.
And it's deploying things. It's going through and bootstrapping itself. And pretty much what happened when we created the initial admin node, it added just the Crowbar admin node role. And then from there, the system has enough intelligence to figure out, based off of the role dependency chains, everything else that it needs to get a Crowbar admin node up and running, and deployed them and built up the graph in the right order to make that happen. And the node role bindings that it has are actually displayed in proper dependency order. So all these dots are going to march from left to right.
And this is the graph that's stored in the data model.
Well, the actual graph is here, and it may
It's a
eventually
level
someday
of-
be useful. But right now, it's not really useful because we aren't ordering it by anything. It just shows the connectivity.
You think about turning it sideways so it's easy to read, instead of having to turn your head and see what the description's on?
This is a result of like 2 hours of hacking. There's a lot to do on that graph.
Okay.
Yeah, but if you're talking about this order, the reason that we have it this way is we anticipate that there will be more nodes than roles.
1,000 down,
Yes.
20 across.
Yeah.
It's just hard to read when you have to turn your head sideways to read what those things are doing.
You know, my hope is that you don't really care
Yeah,
for the most part.
Unless you see a red
The reason we turned it sideways to begin with is because if it's straight across, it scrolls off the edge of the page no matter how wide your screen is.
So
We could put a tooltip over it so it goes horizontal.
There is a tooltip. There is a tooltip.
So if you've got more than a small number of nodes, you could need some sort of filtering on there so you can watch your subset of them.
Yes,
And that's what deployments
that's what
do.
deployments are for.
You'll see that in a minute.
The logic behind deployments is that deployment is essentially a set of nodes that you want to do something.
Cool. Now how about maintenance and monitoring?
I hope you like APIs.
Customers don't. They want to see something that's done for them.
Well, for monitoring and whatnot, you're probably not going to use Crowbar directly for that. You're probably going to use Nagios, Ganglia, whatever.
The expectations is deployment.
Yeah.
Does the interrupt interrupt stop, or does it just pause?
Let's not push it and find out right now.
The goal of what interrupt would actually do is it moves the blocked, all the to-do nodes to blocked.
Yeah, so it's essentially a pause.
Okay.
But probably not a good idea to do
Probably
that.
need to take that off the screen because it worked like a long time ago.
Yeah, don't push the button.
So.
All right, and now our admin node is deployed.
So
Yay.
we are now at the same point that you would have been if you finished a Crowbar 1 install, right? Because Crowbar 1 did all this chef work before you could touch it. So the big difference here is that because of the wizard, we actually could have gone in and modified things before Crowbar did it. Crowbar actually bootstrapped itself using the script jig, which is why the script jig is so important. So it installed the chef server and chef client using the script jig on itself, and then it used the script, the chef server, to do all the other deployment work.
Yeah.
It's bootstrapped.
So
That took us a little
now,
while to get.
in about probably 15 more seconds, you'll see 4 other KVM screens pop up, and it'll start bootstrapping 4 clients.
I want to know what you were wrong when you drove that one.
It's there we go. The script jig is actually work that came from the ServiceNow engagement. Predominantly, that's where a lot of the design conceptualization comes from. So ServiceNow showed us that we had to have the script capability, and then once we realized that we needed it, it became very useful in this role simplification. And that was the other, if you're used to the original Crowbar 2 design, there were a couple of massive simplifications. The first one was that we used deployment as the scoping boundary instead of bar clamp. So that's a huge shift. It's much easier to comprehend what we do because we actually have deployments as handles.
Yeah, if you want your OpenStack deployment, you throw everything you need for that. You throw everything you want in that deployment. You know, your OpenStack specific database, your OpenStack specific set cluster, your Keystone, all that, all goes in the same
deployment.
What you're actually doing.
Yeah. It was a huge simplification. The model got much easier. And then the other thing that made this much more rational was that a role is tied to a jig. Not multiple. Originally, we had it way too complex. We were trying to make a role implementable by 6 different jigs, and the model was really complex. When we did a role is implemented by a jig, everything got much simpler, and that's when we actually picked up the pace and started making a lot of progress. Those were the big innovations with this. That and the node role having a state machine was a big deal. That it's its own, because that's what's cool. Each dot is actually its own state
original
machine.
design. What turns out what we have now as the node role graph was actually dynamically calculated every time we need it, and that turns out to be a little crazy. Yeah.
So what
you're doing right now is you're simulating the discovery of four nodes, right?
Oh, I'm not simulating it. I'm doing it.
Yeah.
It may be simulated in the sense that these are virtual machines and not real machines, but the underlying logic is exactly the same.
So,
We're running in the test mode, like how we do in Crowbar 1.1.
this is the smoke test framework. Yep. So it's for people who don't realize it.
They've registered themselves.
Victor's just using the smoke test framework. So this is built-in behavior for Crowbar.
And when that screen refreshes, you'll see what I'm actually. There we go.
Woo!
Yeah. So at this point, the nodes in Sledgehammer have gone in. Notice they didn't exist. Registered themselves. When they registered themselves, they got their free default set of node role bindings based off of wanting the Crowbar managed node role. And the Annealer immediately noticed, hey, I can start doing more work. And so now it's annealing them all. And it's doing all of the work on the 4 nodes in parallel.
Would you jump to the Annealer page so that people can... I know this is fun to watch.
I'm sorry, I missed it earlier, but can we now have machines with names other than the MAC address?
No. Never.
You can have aliases. You have aliases just like before.
Yeah.
It is possible.
Those aliases actually show up on all the places that the MAC address would.
Yes.
Yeah.
Because right now in Crowbar 1 it doesn't.
This is a database-driven system. It's much more manageable like that. Yes.
Just so you guys know, the actual names of the systems are actually really important to do. Inside of the actual DNS name of
about that.
and-
In other words, if you can't make the name, the primary DNS name, something other than the MAC address, I'm pretty much stuck with it.
I understand, and it's very doable, especially if you know the MAC addresses of the systems before you deploy them.
Okay, now the Annealer's work is finished.
So the Annealer is the work queue
Deployment.
of what's going on.
And all of our nodes are discovered.
Wait, so hold on a second. So the page we were just on shows you the backlog of work that's coming, right? There's a lot of ways to visualize. This is an awesome screen. I think this is like the money screen for Crowbar 2. But there's other ways to look at the system as a deployment's going on. So the Annealer shows you what the pending work queue. You can look at, there's a system overview that shows you this is a functional view, which actually breaks it down into, can you see how it's right here?
Yeah, mouse issues.
Oh, you have an old Dell. If you saw this mouse. No, you can't. There we go. This is actually,
No,
I
it's
just
more,
cleaned up
it's
the
not
colors.
mouse issues with that, it's mouse issues with my touchpad.
So this actually, I cleaned up the colors on. This is a functional breakdown. Once again, you see the node, if the node roles were changing, you'd see them changing. This helps people visualize the fact that we have all these roles. This actually puts them in a layer cake view so that you can be like, oh, okay, I'm deploying OpenStack or Hadoop or Ceph or something like that on top. Oh, we still need to deploy Ceph, so we'll get to watch this get built up.
That's what I'm going to do next.
Okay, so deploy Ceph, and then we'll show people, these are, you can also see these
Let's
from
create a new
a
deployment
node
called
view
Ceph.
and from other things.
Bam, new deployment. And because I know Ceph is going to need a network of its own called Ceph, I'm going to create it here. Ceph network.
And you can drill in and edit more things on that, like subnets and stuff.
I can, but I don't need to because the Ceph part right now uses IPv6 for everything.
IPv6?
Yes.
Awesome. That's pretty cool.
Go back to my Ceph deployment. Get some nodes.
Oh, yeah, it's worth noting, Crowbar 2 sets up all the IPv6 networking necessary, and it uses IPv6 as its preferred routing if it's available.
Mm-hmm. It sets up quad A and single A records and DNS for all of it. All of our forward and reverse lookup zones that you need.
So our friendly bulk edit screen, Victor put some nodes into the...
Now we've got nodes! Yay, look at our nodes. Let's have some roles to go along with those. We need a Cepmon role. We need SD.
So we're going to build a wizard screen in front of this to do it in one shot.
And let's bind them.
So the process of binding, he's just clicking the intersection.
Yep.
And it's smart enough to then resolve the other dependencies.
Yep, and it automatically figured out what else it needed.
Is it also smart enough to know that, like, I should only have one, like, if something has a master, only a single master, it's smart enough to know that if I click a different one, it removes it from the original one?
No.
Not smart enough for that yet.
You can still run with scissors.
Okay.
That's going to be, I mean, that's wonderful for a small group. That's going to be really massively tedious for thousands of servers.
Yes.
Yes. That's why we're going to put an orchestration engine on top of it. Probably Steel Heat can use it.
Yes, that's the plan.
Yeah.
And some wizards and things like that.
I mean, pretty much what we've got here is just enough to proof out that, you know, we can build the graph and do its thing.
That's right. You're right. You're right. So,
commit.
so once the blue diamonds are proposals, you could have clicked on those and edited them if you wanted to change the defaults.
But I don't want to.
Is there a key for this so that the person knows what they're doing, or do you just hover over it and it tells you and gives you a pop-up?
I don't understand. If you don't know what you're doing, you're going to be
you have a
lost.
yellow circle, you're going to have green. Is there a key here, or
Yeah, if you hover over them, it'll tell you what the state means. You'll get text for the state.
It doesn't do it yet, but if you actually click on it.
It should. It should give you hovers for what it means.
Not in that view. If you hover over it, it just...
That's a pro. It should. It's just broken.
But obviously a lot of improvements can be made to the UI, I guess.
Oh yeah. I mean, we're not saying this is going to be the final UI, because
So I would request either a hover or a key.
fair
I
enough.
wouldn't get too hung up on the UI just yet, guys. Just
Yeah.
understand the engine that's happening underneath it. These are not by far the final UI screens.
Yeah. Fair enough to show what's happening in the engine, which is frankly what I care about a lot more for now.
Would you go back to the overview view?
Installed before stuff could be deployed, or is that just right now just all wires and individual?
I'm sorry, I only caught the second half of that. What was that?
Yeah, so with our dependencies, just like right now we talked earlier about, to install Nova, you have to have MySQL and everything prior to this. Is that not required now?
Ceph doesn't
Is
use
that,
all those.
whoever, if
can't
that's
hear
not
it.
Kurt's dog, but whoever has the dog mute,
And if that is Kurt's dog, barking came at the wrong point.
I think he was wondering if the database is not.
Dependencies is that required to install before you did this, or is this just wired to?
So Kurt, that was for the OpenStack dependencies that we had
and
there.
all that. Yeah, Ceph doesn't use all those.
This is Ceph standalone, right? So
Okay.
Yeah, Ceph doesn't require a database or RabbitMQ or any of that.
Okay. Alright.
Good,
So what does it use? What does it use?
uses itself.
It uses itself. Yeah.
It's a good question, but I think what Kurt was kind of drilling into is stuff that you talked about earlier. And if there is a series of dependencies and you put in only the final role, the system will build out all the upstream dependencies.
Yes.
That's what I'm asking.
That's what I did here initially. When I was building that out, I only added the CephMon, CephOSD, and CephMBS roles. But when I added the first CephMon role, it figured out that this deployment's going to need these dependencies as well, and it automatically added them. Like it automatically added the provisioner OS install role, which is what actually does the OS installation. It automatically added the network Ceph role to the deployment, which is the role that provides the Ceph network. And automatically added the Ceph config role, which carries around some global configuration data that the cluster needs.
So I want to show a little bit more Crowbar 2 for a second. Drill into one of the nodes, please.
I have a quick question here for the dependencies. If, let's say I have a dependency to have a service somewhere, and it could be on any of several nodes, what methodology does it use to pick where to put it?
The methodology that it uses is if there is a service in the same deployment, in the same node, it'll pick that first. Otherwise, it will pick a service that's living on any random node that's in the same deployment. If it can't find that, it'll try to pick it from the parent deployment and so on and so forth until it gets back to the system deployment. If it can't find it there, it gives up.
So currently we can drag nodes, sorry.
There's no dragging
There's
of
no
nodes.
dragging. So we cannot specifically say, okay, deploy this component or this node role here in this node.
No, we did that.
We did
When
that.
you did the grid, when you
Silence.
click that intersection, that's picking the node. That's putting this service on this node,
As opposed to dragging.
as opposed to dragging it.
radio button.
But you just added the node role and it automatically put all those LEDs in different machines. You didn't drag the nodes on the role.
He
It's just
clicked the
opposite
intersection.
to what we do right now in Crowbar 1.
Well, are you concerned about the way that it picked its prerequisites?
You define the nodes as going to on that intersection.
You had a bunch of nodes
So how do you
and you
select
added
them?
rows and it automatically picked the nodes
Well,
from the class, from the group that you had. You can't specifically say that, okay, 07 is going to be the controller or whatever.
But he did.
You did?
Yeah.
I specifically
Sorry, I think I
said
just missed it.
04, 07, and 0A are going to be CephMon nodes.
He actually was clicking the intersections, and a plus was coming up, and he was clicking the plus.
You can't see it here because I'm actually in the middle of something. But if this was in proposed, if I hover over a blank space, it'll pop up with a green plus sign. If I click that, that means bind this node, that role to that node.
In that matrix.
Yeah.
Sorry, Shelley, I think you had some question.
My question, and I didn't quite understand his answer, was Let's say I'm doing something and it needs DNS as a prerequisite, but DNS hasn't actually already been bound or installed anywhere. When it goes to figure out the dependencies, let's say whatever I am installing is on 04, how does it choose where to install DNS?
Right now, it's incredibly stupid, and it will try to bind it on 04. Yeah, absent of any other directives.
But if it needs a DNS server, and there is no DNS server, then it fails.
No, right now...
It'll do it for DNS
Right
client.
now, it'll do it for everything. If it needs a prerequisite and it can't find it, it'll bind it in that deployment on that node.
Okay, that's fine.
The
Which is why
logic
we do that for the Crowbar admin server.
The logic is subject to change depending on the need. It's the most expedient thing for now.
Right.
Okay, thank you.
As we grow, as we try to add more intelligence about where we want to place things, that logic will have to change.
Right.
But it's what works right now. Oh yeah. Oh yes, it will. But yeah.
You don't call them bar clamp anymore. We just call them.
No, bar clamps still exist.
So there's a bar clamp. There's bar clamps in the UI.
Yeah.
Oh,
Yeah, we still have all the bar clamps. They're just not as important anymore. They're basically just packaging methods for roles.
I thought you created a set thing, right? When you were creating this.
Yeah, I created a deployment called set.
So it's a deployment.
Yeah.
Yeah, bar clamps are just bags.
So is there one-to-one
Is there a
mapping
one-to-one?
between? Yeah.
Same places. Hmm?
A one-to-one what?
Bar
Mapping
clamp
between the bar clamp and the
rows.
No.
So it's-
There never was. We just didn't. You guys used roles all the time, but people didn't realize that they were using them because they were hidden in the attributes.
One-to-many.
Yeah, I think that's part of the problem is that for you guys working with the system quite often, the roles actually make a lot of sense. And to somebody actually doing a generic deployment, it's the bar clamp or the collection of roles that actually make a difference, not necessarily all the specific names of all the specific sub-roles.
Right, and that's why we created the functional view. So if you go back to the functional view, and we'll probably end up creating these for OpenStack and for each thing. But that functional view, system overview, is designed to help you translate between this bunch of meaningless names and actual. See, now you have application service level stuff, and that helps you see that you've actually built up capabilities.
So each dot is a node?
Each dot is a node role.
Node role. So you don't know how many, you don't know what's on what.
You hover over them. You hover over them to get details for that. And we haven't come to the Nodes UI page yet either. So if you go to the Nodes UI page,
I guess it's, Audra, I guess it's more accurate to say each dot is a role on a specific node.
yes.
But a node could be associated with multiple dots.
So
It almost always is
want to
associated
see
with multiple dots.
the nodes and then the roles that are on the nodes, not all the roles.
Well, that's part of what the grid is showing.
So go drill into an individual node. So remember, one of the big complaints we got, if you go into an individual node, you can show the node roles that are on it. This is really specific to address a major complaint with Crowbar. In Crowbar, we did a lot of stuff, and you never actually knew what was happening. You didn't know what was going on the node. You didn't know what was going on in the deployment. You really could only get the highest level, sort of sketchy feedback. What this does is, this is very explicit. If you're not talking, please mute. And this is very explicit about what's going on with this. So this is a node, this is an individual node, and you can see exactly what's working on that node, what's coming on that node, what's in the middle of being deployed on that node. From a understanding the system perspective, we are very, very transparent about what's going on, which is one of the major design goals here. So, Audra, every one of those dots is actually reflected for each node, and you can actually drill in and see exactly what's going on. So if a node is in transition, like it used to be, you can actually drill into that and say, I know exactly what's being installed on that node at that time. If it's an error, Victor's stuff is all going to work, so there's not going to be any errors. If it's an error,
well, that's the theory. Anyways.
That's the theory. If it's an error, you can actually know exactly what node rolled through the error, and then node rolls actually post logs, and you can see exactly the logging information. Sorry. The logging information that is being collected for that. We're not really using the camera anyway.
Yeah, like for the last deployer client run on D525400123004, I can look at what the output of the chef client, the output of the chef client run for running just that set of roles.
Oh, that's nice. So that's on the GUI.
Yep.
That's a lot nicer.
And if it failed, you'd see the failure message.
Yes.
Yes.
It just failed. Which of 15 different logs in 15 different places do I look at? No, I don't.
You click on the one,
like that.
you find the one that's red, and you click on it, and it's bam, there's your log.
Right. And this is going to make a huge difference if you're troubleshooting a recipe or a cookbook or a deployment. And
now everything's green.
And if it fails, you can attempt to rectify the failure and retry. And all the other work that's downstream from that is held because of the error. So we don't keep running a deployment if there's an error. You can retry and see if it tries it again, and then check again and see what happens. So from actually operating a deployment, this is much more manageable, much more rational. Where the lead. So. Cool.
That's the end of my demo.
Is that the end of the demo?
Look at other things.
I want to make sure we cruise through all the screens that are meaningful here. Jump into the network screen for a second. So under networks, what you'll find is we already showed this. If you click on a network, you'll see the
admin network.
Yeah, it has stuff. So the admin network, actually, you can set a whole bunch of information about it, and also its ranges. And I don't think I finished the UI for router.
I don't think we have.
But you can actually update and add the ranges. So if you were building a system, like Tim Scott was going to ask Tim to do a 100-node deployment. You might find that you need the DHCP range to be bigger than 16. Actually, it's 60 right now, so 60 might be enough. But you might find that you need to change the ranges. This is where you'd edit it, save it, and then do your do your deployment. So if you do it here, then you don't have to worry about it, right?
So what if you want to change it downstream?
You want to change it afterwards.
So the admin, the other
admin network, that's tricky.
Right, it's tricky. It's not impossible, but it's tricky.
For the other networks, you should just be able to go in and edit your ranges and change them. As far as editing IPs that have actually been deployed, that's also tricky.
I'm just thinking that it's awfully easy to underestimate what you're going to need up front, or overestimate and take out huge chunks of networking space that you need to reuse for something else at some point.
And well, that's also part of the reason that I baked in support for IPv6, because you don't really have to care at all with IPv6. The smallest subnet you can give something is a /64, which is a lot of space.
So that's one of the things that I'm hoping we'll be able to do is help people be IPv6 default, and maybe even start pulling back some of the IPv4 networking. Okay, so go back to the subnets under network. Not subnets, the ranges. What's the other option on the networks?
That's
interfaces.
Oh.
So the other thing from network JSON is the bus interface map, where you actually set the if you have to add a bus order. Right. So I know Randy was fighting for this on the 620. This is where you would do it in Crowbar 2.
We've had me type in Power Edge C or R620 and then throw in your new bus maps and that.
We haven't brought back in the pretty UIs for.
So there's a data bag that already defines this and it's caught by default or something. Is that where the data came from? The default.
It's in network JSON.
It came initially from Network JSON, but Network JSON doesn't exist anymore, so this actually lives in a database table that the network bar client manages.
And then, right. And there's also a graph that shows the intersection between nodes and interfaces, which is very primitive right now. Handy at times. Right.
Yeah. And one thing you'll note on that graph is that all the Ceph ones say not set, because they're all IPv6 and we don't show that right now.
I need to fix that.
For IPv6, by default, we don't actually allocate any address spaces. You just take the last 64 bits of the MD5 sum of your host name, and that's the host party graph IPv6 address. Because 64 bits is a lot of space for, cryptographically secure hashes to wander around in. The odds of collision is lower than something else in Crowbar horribly breaking your stuff anyway, so I don't worry about it for now.
Deployments, I think we've shown all the stuff under deployments, except for roles.
Yeah, and roles just shows essentially what roles are mapped to what jig.
And there's a template roles, so there is template information that comes in with the system that determines the default values. You'll notice that roles are grouped by jig because they're bound to jig, so it's a logical grouping. And one of the cool things is you can see all the upstream. So if you're wondering what a role depends on, you can see it from there. Under utilities.
Provisioner server depends on a lot of things, which in turn depend on a lot of other things, and that essentially is its space in kind of the role dependency graph.
And then under utilities, Bootstrap we already showed you. Exported items is the same log stuff that we had before. Installed jigs shows you jigs, which is not a surprise. You'll get green dots if it's working. There you go.
Rumble and blue dots if it's not. We don't turn the test jig on.
Actually, we don't turn the chef jig on in test mode.
Yeah, so Rob, I asked for the export of your configuration options. Is there a way we can add that, or just a feature request?
I haven't done it yet. That's a feature request. Yeah.
Okay.
And then
users.
Users. It's been there for a long time.
We've got 2 users. Look at that. And one thing you may note that's funny about the Crowbar user, it's using a 4 and 6 address. That's because the Crowbar web server is actually running an IPv6.
Do you have to do anything on switches for IPv6?
Hmm?
Do you have to do anything network hardware-wise, like switching for IPv6 support?
Not unless your switch is trying to be overly intelligent.
Scaffolds are they're developer tooling. Right now they're on by default. They'll be off by default eventually, but they let you poke around at the native model. So if you actually want to see the underlying data for something.
Do we not have one here for roles?
We should. Maybe not. Oops.
Networks.
You could actually just type scaffold/roles and it would be there. But yeah, this just shows you the data, and then help provides the help system. And then for Crowbar 2, the help system is actually an integrated. We pull in all of the data.
Oh.
It's weird. It shouldn't even work in that case. That's strange.
Yeah. But yeah, this just lets you edit stuff directly in the database.
Which is not advisable.
That's interestingly terrifying.
Which is why it's developer only, and we're going to kill it.
And then if you I don't even use it, frankly, but it's handy every once in a while. And under help.
Wow, where do we get the ISO on? Is it on Jenkins if you want to start playing with it?
I think the Jenkins, Scott, did I fix the Jenkins server by adding the missing dependency?
Yeah, it's been running builds all day, man.
Sweet. Yeah, we've been doing pulls all day. Good. So yes, Jenkins. And then if you go to docs, one of the things that I will encourage.
You need help?
Help, sorry. Yeah, it's the docs control. Either it's the same one. So And I know Matt Midland is still tweaking this, so bug him if you want changes. Because I know like the jump to list is much longer than it's supposed to be and stuff like that. My CSS is hacky.
The amazing options.
It's awesome. Yeah. So the idea here is Crowbar 2 docs are not intended to be, tossed to Dale over the fence at the end and generated as a PDF. They are an integral part of the code base in the /doc directory. So please, as you use the system, if you learn something, go to the doc directory, write it down, make sure that it's right. There is a dev guide. Every object in the system, every API in the system currently have at least stubs, right? The UI screens, I'm trying to catch up and get stubs for all the UI screens, but there is a user guide where every UI screen should be. Even if you don't see a file for it, every page has a base level file. Just put the data in the file and we'll decompose it later. But please, as you use the system, add to the docs. You don't even have to do it in here. If you don't have the code checked out, you can go to GitHub and edit the docs live in GitHub and save, which is perfectly acceptable. Right? There is no, you do not have to go. It's fun to go through the pull request process for doc changes, but it's not required. If you want to make a doc change, make the doc change. We want people to work on docs.
There's nothing fun about doing pull requests.
Yes. Yeah. It is fun. It's rewarding. Builds your character.
Just take up smoking. Smoking cigarette every time you go through the pull request list. You'll habituate yourself.
But yeah, there's basically no overhead.
Well, I didn't say anything about that.
Yes, you can create docs in GitHub without the dev tools. So in GitHub, I'll bring this up since we're talking about it. GitHub has a white background and should, oh, this is your screen.
Yeah, you probably want to exit the screen.
I'm going to close this and take this away if I can see it. Yay. And one of these tabs is GitHub.
Because it's after 4 now.
Oh, so I've got to go. This is GitHub. No, that's Stack Overflow. This is Docker. GitHub. Okay, so in Crowbar, this is actually my repo. Crowbar. So most of the docs, because of the way we lay things out, are in the bar clamp Crowbar. Here's the doc directory. Here is the user guide. And if I want to create a new document, I click that button, create new file. And it will create a new document for me. Let's see, I'm missing the, there's networking, nodes, actually I already created all the stuff, scaffolds, users. So I can create new, you can actually create new directories here too, by the way. But yeah, so if I need a new markdown document, I click here, I create the new markdown document. I should use one of these as a template, which looks like this. Here's the raw, and I can, so our docs by default need to start with at least one £, depending on how deep you are in the thing. So you would put pound, the name of your document, and then you would start writing your docs using Markdown. And then when you were done, you would save it, and they would now be part of the docs. I'd commit the changes, I'd write a little summary of what I did, commit the changes, and voila, docs would be updated. If you are working on a bar clamp specific document, it should actually be done in the bar clamp specific to it. So the networking docs are actually in the, this file shouldn't actually be here, it should be in the network bar clamp, and we'll rationalize those things as we go. Because the Crowbar system coalesces all the docs. So all the Ceph documentation actually should go in the Ceph bar clamp. That way, if you don't install the Ceph bar clamp, you don't have any Ceph documentation confusing you. All right, now we've gone over. What I would ask is review the training guide that we went through, add to it, please. if you cruise the docs and find things that you think you can explain, certainly you can do it better than we did. So add to the explanation, and then save your questions up for tomorrow, because we're going to spend 2 more hours going into the nitty gritty of how you actually develop against this tomorrow.
How soon do you think the UI is going to be semi-baked? I know it's never going to be completely finished, but relatively slow.
I've been, we're welcome to discuss this at length. I'm going to stop the recordings.